Math group. Here's a hopefully quick screen recording for what's happening with this Desmos activity. This was in Unit 2. It's our second Desmos activity in class for Unit 2. I asked you some questions about the next quiz. For knowing what types of problems we'll be expected to solve on the quiz, you want to check out that list of objectives that is in every unit. That's the thing that drives our quizzes, and so make sure that you're keeping an eye on that. All right. The pre-quiz number 2 is mandatory in Math 095. It is optional in Math 115. Doing some work on true and false statements and counter examples. All cats are furry. I put false. The picture over to the left is supposed to be one of those hairless cats. And so that would be a counter example. But some classmates did say that cats are mammals and mammals have hair. And so they wanted to go with true. And I think we could be in an argument about that. That would be okay. I agree this cat probably has whiskers and probably little tiny hairs around its ears, things of that nature. And so if you wanted to argue that that was furry, I'd be okay with that too. This one I'm hoping we will agree on by the end. When we subtract two numbers, the answer is always less than the number we start with. That is false. I have a couple of counter examples here. 5 minus 0 is 5, and that's not less than 5. And if we did a subtraction of a negative number, 5 minus a negative 2 equals 7, 7 is not less than either of the numbers that we start with. So we have a couple of counter examples for this false statement. I give you a definition of a counterexample. I want you to be able to make a counterexample if you declare that something is false, like how Nevada is the only state in the U.S. that starts with N. I listed a few here: New Mexico, New York, North Dakota, North Carolina, things of that nature would be good counterexamples for that statement. If we square a number, the answer is greater than the number we started with. That is false. The counterexample I was thinking of was something like a half times a half gives us a fourth. The 1/4 is smaller than the 1/2 that we squared. By the way, squaring means take a number and multiply it by itself, if you've forgotten. 0 times 0 just gives us 0. That's not greater than what we started with. And 1 times 1 does not give us something that is greater than what we started with. It's still just 1. So few counterexamples there. It is easier for me to make up a false statement than a true statement, but don't let that get in the way of declaring something as being true. Okay. Two more of these. If we add two even numbers together, the answer is also even. That one is true. And we could prove it. If we were in class together, we could quick do a little proof either with some algebra or maybe a diagram. If we add two odd numbers together, though, the answer is not going to be odd. That one is false. When you add two odd numbers together, that will give us an even number. So this one down here, 5 plus 3 equals 8, that was intended to be a counterexample for the second statement. And then 6 plus 10 equals 16, this one on top, this was intended to just be a trial for the top statement about two even numbers, adding them together, giving you an even number. Another style of problem we need to work on in this unit are these combo problems or weird zoo problems, where we have a couple different styles of things running around, maybe a couple different animals or a couple different types of coins, and we need to figure out how many of each type of thing we have based on some information. So in this one, we have only badgers and ostriches in the zoo. There are 25 animal heads and 78 animal feet. This helps us because 25 animal heads lets us know there are only 25 animals at the zoo. And 78 animal feet will help us because badgers have 4 feet each and ostriches have 2 feet each. So armed with all of this information, we can puzzle our way through to figure out how many of each type of animal are available. There's a couple different ways to do this. I've started a guess and check table over here on the left. And so if there are going to be 25 animals in the zoo, I just kind of started in the middle. I said, oh, okay, maybe there's 10 badgers and 15 ostriches. And then I check on the feet. I have 25 animals total, but I got to check those feet. So 4 feet on the 10 badgers each, 2 feet each on the 15 ostriches each. And when I add all of that up, I got 70 feet. And I wanted 78. So that top line didn't work. So I try again. I need more feet, and the badgers have more feet. So let's bump their number up. 12 plus 13 is 25 animals. And then checking the feet, 4 times 12 plus 2 times 13. And I came in over here. That gave me 74 feet. That was closer. And then I tried 14 badgers and 11 ostriches for my 25 animals. I checked their feet, and I think this time it comes up to be 78. It does, 78. So with guess and check, I was able to say, okay, 14 badgers and 11 ostriches. That's what we have going on at the zoo. If you're not a guess and check fan, that's okay. You can work with some equations to make this happen. And that's what's going on in the box where I'm typing here. You could work a couple of equations. You could use X for the number of badgers and Y for the number of ostriches. When we add those two together, we should get 25 animals altogether. And then we incorporate their feet. 4 times every badger, or the number of badgers, plus 2 times the number of ostriches is supposed to give us 78 feet. And the strategy with these two equations is to take the simpler one and solve it for one of the variables. I'm going to solve it for y, and then substitute that expression into the more complicated equation. So I left you a note here. Solve the top equation for y. When we do that, that means we're going to take this x and subtract it from both sides. So we get y equals negative x plus 25. We'll take this expression for y and substitute it into the second equation where the y is currently living. And we do that with parentheses. So 4x plus 2, parentheses, negative x plus 25. Close those parentheses. That'll equal 78. And then we start working on that equation. We do distribution with the 2. We'll get 4x minus 2x plus 50 equals 78. We can combine like terms so that 2x plus 50 equals 78. And I've left out the writing for a couple of steps here because it's a bit cumbersome to put into the typing area. But we would subtract 50 from both sides of the equation. And when you do that, you'll get 2x equals 28. And then to get x all by itself, we'll have to divide both sides of the equation by 2. And we'll get x equals 14. And x was supposed to represent badgers. So we get 14 badgers. And then use that helper equation again, that little equation, for negative 14 plus 25 is 11 ostriches. 14 badgers and 11 ostriches, just like we came up with here, but we do it with algebra instead. You can choose your method that is the favorite for you. And I left you a video tutorial in our playlist in this unit that will also let you use a Desmos graphing calculator with these two equations to work your way toward the answer. So it's kind of a combination of algebra and graphing if you're interested in that. And I always encourage you to at least look at other problem-solving strategies. So let's see. This one wanted to know how many of each type of animal are there? 14 badgers, 11 ostriches. How do we figure it out? Guess and check. We can use a little bit of algebra. You might have had another strategy in mind. Using the answers from the previous screen, I'd like a statement like this about how many more or less badgers there are than ostriches. There are 3 more badgers than ostriches at the zoo. We had 14 badgers and 11 ostriches. So this is the kind of statement that you would see on a quiz in Canvas for a final answer, rather than selecting answers from a list. I want you to do the work in a forward way and then make a statement like this. This one is another kind of combination problem, but it has an a geometric component to it. This one reads, the length of a rectangle is 1 more than 2 times the width. The area of the rectangle is 55 square centimeters, and I'd like to know the perimeter. This one is best done with guess and check. So I have my table set up over here. We're going to guess on some widths, and maybe you call those W. The lengths, it said 1 more than twice the width. And actually, this should not be here. Let me put this in the chat box or the little text box over here. The thing we're going to check is the area. And for a rectangle, the area is length times width. So I come along and I start picking some widths. Maybe I pick 10. Then I find the corresponding length. So 2 times 10 would be 20, plus another 1 would be 21. And then to find the area, we can do 10 times 21, and that'll give us 210. And that's too big. I wanted it to be 55. It's way too big. But I know that a width of 10 gives me too much, and so I need to go a little bit smaller. Or I need to start chopping it down. Maybe I try 8. 2 times 8 plus another 1 would be 16, plus 1 is 17. And then I need 8 times 17. That is 136. Asking my calculator for some help. I'm hoping for 55 for an answer, and it's still not there. Let me chop down further. Here's 5. 2 times 5 plus another 1 is 11. 5 times 11 is 55, and that's what we wanted it to be. So I know that my rectangle measures 5 units by 11 units. Oh, let me just type in here. Rectangle measures, and they're centimeters. 5 centimeters by 11 centimeters. I'm so happy. Smiley face. All right. The question, though, wasn't about the dimensions. It was about the perimeter of the rectangle. And the perimeter means we need to add all the way around the outside. So, yes, there are formulas, but we can just go and do all the adding. 5 plus 11, and then if we proceeded, we'd have another 5 and another 11. And when we do this, I think we'll have 22 plus 10 is 32, or 2 sets of 16 will give us 32, and it is 32 centimeters for the perimeter. And that's how we would end this one. The algebra for this one is pretty sticky, so I would stay away from that if I were you. It takes a bit more than what we use in this course. It's not as friendly as the last one, algebraically speaking. The next screen was about the objectives. Every time we have a unit, I give you a list of objectives, and I would like you to look through those and have some thoughts on what are you comfortable with, what are you least comfortable with. I'm opening mine up. Multiplication principle of counting. That was the stuff where we said, oh, if we're making a choice in each of these categories and we have this many options in each category, how many possible options are available to us? That kind of thing. Those came in a few styles. Counting principles in scenarios with replacement and without replacement. So more counting there. Basic probabilities and know why they work. Venn diagrams. There's the combo problems, next one down. The weird farms and the coins and the rectangle thing we just had. Counter examples. We had handshake problems. And then this one down here, apply a comprehensive approach to problem solving. I think you'll see that in every unit. It means be able to solve problems and most often know more than one way to get there so that you can double check your work. So that's what to do on that page. And then this last one, how to prepare. I'm looking for active methods of preparing for quiz number 2. Sometimes students tell me, I'm going to look over my notes. And that's nice, but it's not terribly active. You want to think about, what will I ask you to do during a quiz? I won't ask you to demonstrate how great you are at looking over your notes, but I will ask you to solve problems. And so active preparation for a quiz will require that we have to actively go and do more problem solving. That might be watching the videos again and pausing them, solving the problems, and then checking your work with the tutorials. It might be looking at problems in the course pack again, redoing them without looking at your old notes and then checking them, and going back through Desmos activities. Don't look at your old stuff. Pretend like it's brand new. See what you come up with and see if you're getting to the right spot. You also have that pre-quiz number 2 to help out. I had another thought and it left me. Pre-quiz number 2 can help, but it's not a comprehensive, it's not a complete version of how you should be preparing for quiz number 2. If you need anything, please reach out. I'm right over here in cyberspace.